Okay. So we're going to learn a method today known as insertion sort. Okay. Name of this method is insertion sort. So if you are given one array like this initially, okay, you will be asked to sort it either in ascending order or descending order. So insertion sort will require n minus 1 comparisons to get your output. So if you're given 6 elements, it will require 5 iterations to get your proper output. Okay. So the way it works is, in iteration 1, okay, you compare the first 2 elements in your array. You compare, in this case we are comparing the element that is in first position 5 with the element in the second position, that is 2. So if you want it in ascending order, that means 2 should come before 5. Okay. So since 5 is in the first position and 2 is in the second position, we swap these two values with each other. So I exchange the values of 2 and 5. So I get 2 in the first position and 5 in the second position. Okay. So I swap these two values, elements, and I get 2 in the first and 5 in the second. Once I do that, I proceed to the next iteration. In the first iteration, I only compare the first 2 elements. Okay. In the second iteration, I compare the first 3 elements. In the first 3 elements, you can see here we are having 2, 5 and 4. Okay. First 3 elements we are having is 2, 5 and 4. So now we see whether they are in the proper order. If they are not in the proper order, then we swap them with each other so that they are in the proper order. In the second iteration, basically what we are doing is we are including one more element for sorting. In the first iteration, we had considered 2 elements. In the second iteration, we are considering 3 elements. So once we see that they are not in the proper order, we arrange them in the order that we need. So we get here 2, 4 and 5. So we swap them in such a way that we get the proper ascending order among these elements. Okay. The remaining elements that are there, we just copy them as it is. We don't touch them. Okay. Then the next iteration, here we have done now 3 comparisons. That is, we had included 3 elements. Then the next iteration, we will include one more element. We will include the 4th element. And we'll check whether they are in the proper ascending order. If they are in the order, proper order, we do not do anything. Okay, there is no swapping involved. You just continue to the next iteration. As you can see here in this step here, all the elements are in proper order in the way that we wanted. So we do not do any exchange. We go to the next iteration. So when we go to the next iteration, again we include one more element. So here in the third iteration, we have taken 4 elements for comparison. So in the 4th iteration, we take 5 elements. So when we compare all these elements, we see that one is in the 5th position, but actually we want one in the first position. So we do the swapping of this element so that we get this order, the proper swap ascending order. Okay. So the entire aim of this is we take this one and insert it in its proper position. Okay. We take this one and insert it in its proper position. So this is something similar to your game of cards. When you are playing some game of cards, and when the cards are being handed out to you, you normally arrange them in some order. Okay. So suppose you get your cards, you keep getting your cards, you arrange them in ascending or descending order according to the type of card it is. Okay, whether it's a diamond, it's a spade, it's a flower. So something similar happens here. As you include each element into the sorting, in each iteration you increase your elements, you take that element and you insert it into its proper position. Okay, so for example, this one here is taken and inserted it into its proper position, that is here. So 1 should have been in the first position, therefore we insert 1 in the first position, and all the other elements are shifted to the right. Okay, so if you see in every other iteration also, we have taken this new element and inserted it into the proper place. Therefore the name of this sorting algorithm is insertion sort, and it is something similar to what you have already been doing when you have been playing a game of cards, for example. Okay, so in the next iteration, similarly, we take the we include one more element for sorting. So here in iteration 4, we have taken 5 elements. In iteration 5, we'll take 6 elements. When I get this new element, I insert it into its proper place. So I take this tree and I insert it into the third position. When I insert it here, the remaining elements are shifted to the right. So at the end of my 5th iteration, here is where I get the proper sorted array. Okay, so we are basically, all we are doing is in each iteration we include one more element for sorting, and when we include that element, if it is not in the proper order, we insert it in the correct place. After we insert it, we go to the next iteration. In the next iteration, we take one more element and check if the order is proper. If the order is proper, we don't do anything. If the order is incorrect, we insert that new element in its proper position and we go towards the next iteration. And you continue it till you reach the end of the array. So normally you will have n minus 1 iterations to get your proper output. N minus 1 iterations you can say, or n minus 1 passes. So you can have that many number of passes to get your proper ascending order output. Okay. So do you all have any doubts about what I just told you about insertion sort? You can type your questions in the chat here if you have not understood. Is it okay with everyone? Do you all get it? Okay. So now, suppose I want to sort this. Now I have sorted it in ascending order. I have sorted it in ascending order. Suppose I want to sort it in descending order. This same array, I want to sort it in descending order. What are the changes I have to make in my algorithm? Can you try it out on your notebooks? Sort this using insertion sort in descending order. The same initial array, sort it in descending order. Okay, have you managed to do it? Okay, if you are doing it in descending order, obviously you want the largest elements at the beginning and the smallest element at the end of the array. Okay, so you're going to start again by comparing the first two elements. You compare 5 with 2. When you compare 5 with 2, you see that 5 is already greater than 2. So it is already in descending order here. We don't require this second. Okay, there is no swapping involved. We do not need this. Yeah. So we are going to have it in descending order. So this is already in the proper order, 5 and 2. So in the next iteration, we're going to take these elements. We are going to include one more element for comparison. So we're going to include 4. We're going to compare all these elements whether they are in descending order. So now when you compare, you see that 4 is not in the proper place. Okay, if we are going to put it in descending order, 4 is not in the proper place. So you're going to sort it like this. You're going to get 5, 4 and 2. Okay, so you're going to get these elements here, and the remaining elements just copy them as it is. You're going to copy this. You're going to get 5, 4 and 2. You include these elements here for the next iteration. Now in the next iteration, you're going to include one more element, that is 6. Compare this. Okay, so you want it in descending order. This is the new element 6. Is it in the proper descending order? No. 6 should be in the first place. So you will put 6 here. You will get 5 here, 4 here and 2 here. The remaining elements are going to be as it is. Going to get this here. After comparing, you will get something like this. Next, you are going to include one more element, that is 1. When you compare the descending order here, the order is proper. So you're not going to do anything about it. Okay, no exchanges. So you go for the last iteration. You're including one more element. When you compare, tree is not in the proper place. So you will do the exchange. So you will get here like this. When you insert tree in the proper place, okay, you will get something like that. So this will be your final sorted descending order of elements using insertion sort. Okay, did you all get it? Is any doubt here? Anyone having any doubt in any of these iterations, any step? I can tell you about it if you want. So this is the final output that you're going to get when you do this descending order. Is it okay with everyone? Okay, so I think you'll have understood this insertion sort. So let's continue to the next type of sort known as selection sort. Okay, now selection sort and insertion sort are similar but they are not the same. Okay, so at the end of the sorting you will see that it is not the same. There is a slight difference between it. Okay, but it is almost similar. So basically, I will. You can just read this. I will explain this when we go to the example in the next slide. So this is the general way of this way this method works. Okay, I'll explain you the entire process and then maybe we'll come back to this slide and you will understand what is written here. Okay. So consider this example. Say we have an array A of 5 elements. Say these are the 5 elements. Say we want to sort it using selection sort. So we are going to sort it in ascending order. Okay. So just like the other sorting methods that we have studied, this has n elements. It will require n minus 1 passes or iterations to get the proper sorted order. So in this example, we have 5 elements. So we require 4 passes to get the sorted array. Okay. So let's start and see how it works. I hope you all are taking a pen and you all are having a notebook and you all are noting it down what is happening. Okay. So this is your array. We are starting with the first pass. Okay. So basically what you have to do is you have to identify first the search area. So in the first pass, your search area is the full array. The entire array given to you is the search area. So I marked here, this entire array is your search area. Okay. Then the first element of your array in pass 1. In pass 1, the first element of that array will be known as your swap position. Okay. This will be known as your swap position. So in your, basically remember this. Okay. You'll get confused and then you'll make a mistake then for exams. In your search area, whatever is your search area, and the search area does not remain the same every time. Okay. So in your search area, the first element will be your swap position. Remember what I'm saying. Note it down. In your search area, the first element will be always your swap position. Okay. Because now we are doing ascending. If you are doing descending, then you can change that. In ascending, I'm talking with respect to ascending order of elements. Okay. So once you have identified your search area and your swap position, next you have to find out the smallest element present in the search area. Your smallest element present in the search area is 1. Identify that. Okay. So once you have identified your smallest element in the search area, your next step is to exchange these two values. You exchange 1 with 5. You're going to swap these two values. Okay. You swap 1 with 5. So you will get something like this. The remaining values you write as it is. So you exchange the value of 1 with 5. And remaining values, that was 4 you copy, 3 you copy, and 2 you copy as it is. Okay, clear? So once you have done that, you go to the second pass or second iteration. So for second iteration, you take the output of the first iteration. So you're going to take this array here that you got after swap as the input for the second iteration. You're no longer going to take the original array. Okay, take this now. So now for this, I've taken this. This is the given example. Okay, so this is the output of the first pass. So we are not taking this given example, we are taking this output of the first pass. Okay, output of the first pass is this. I'm taking this output of the first pass as the input for the second pass. So again, now you're going to identify the search area. Now you know that 1 is the smallest element. Okay, and it is already now in its proper place. We are going to sort in ascending order. 1 is already in its proper place. So it makes no sense including this 1 again in the search area because 1 is already in its proper place. So now we start our search area from the first element. Okay. So our search area now comprises from element 1. If, with respect to your array, this is at index 0 and this is at index 1. So we start from index 1, the search area for your second iteration. And all the elements starting from 1 will be included in the search area. So it will be looking like this. Okay, this is very important. Remember, your search area decreases. So now, like I told you, can you write in the chat what will be a swap position? If you remember what I told you, what will be a swap position? Which value will be a swap position now? Type in the chat. Correct. It will be 4. Correct. It will be 4. How you get 4? Because I told you the first element of your search area will be your swap position. So this is your first element of the search area, that is your swap position. In your search area, now look for the smallest element. Okay, in the search area. So in the search area, the smallest element is 2. What are you going to do? Exchange both of these values, 2 with 4. You will get something like this. Okay, so this is your second pass. So when you are writing a second pass for your exams and all, you don't have to write this given example. Okay, don't write this part. You need not write. I've just kept it here. You need not keep it. So for now, for your third iteration, you're again going to take the output of your second pass. So can you try this in your books? Like I told you at the beginning, you will have only 4 iterations, and in 4 iterations you will get the output. If there are n elements, you get the output in n minus 1 iterations. So I've shown you 2 passes. Can you try the third pass and the fourth pass? After I'll give you some 5 minutes. After you try, I will show you how to do it in case you are not able to do it. Okay, so I hope you have done at least the third pass. So going to the third pass, so this is the output of your second iteration. So identify the search area. First two elements are in the proper place. So now your search area starts from the second index. Okay. So this will be a swap position, the first element in your search area. Find the smallest element. Again, the swap position and smallest element in this case is the same. So after exchanging also it will remain the same. There is no change. Okay, nothing changes here. So you get the same output. So this is your third pass. So now the first three elements are in the proper place. So again decrease the search area and you will go to the fourth pass. When you go to the fourth pass, you take the output of the third pass, mark the search area, identify the swap position, identify the smallest element in the search area, exchange the two values, and then you get your output. You get your array in the sorted order. So is it okay with everyone? Did you all understand? Any questions about this? What do you mean by that, Siddesh? Only one swap? In every iteration we are doing only one swap. Yeah, Siddesh. No swap in the third pass because the swap position and the smallest element were in the same place, so there's no swap. Okay. So since we are checking while swapping, we are checking if the values are greater than or less than, and depending on that we are swapping. Yeah. So for correct. So for descending, correct. So for descending, we have to swap the greatest element. Correct. Now we were doing ascending, so we have to swap the small element. Okay. So for descending, you have to do the opposite. Correct. What you have mentioned is correct. So now I've shown you an example of ascending. So we are finding here, if you are looking at this initial first pass, if we were doing descending, then I would find the largest element. I would find the swap position. Swap position method is the same. Swap position will be the first element of the search area. But when you are doing descending, you have to find the greatest element. Instead of finding one here, you would have found out 5. So in this case here, Swap position also would have been here, and greatest element also would have been here, and no exchange would have happened. Okay. So yeah, that is what, yeah, correct. That is what you have said is correct, Siddesh. When you are doing descending, you have to find the greatest element. I think you all can try this. Actually, that was my next question to you all. Try the descending. To take this element, the same array, and try descending. Okay. Take this question and you can try it later after the class, because I want to discuss with you some other things and we will run out of time. Okay. So note down this and try it. If you face any difficulty, you can let me know in tomorrow's lecture. Now we are going to sort this array using selection sort in descending order. Yeah, in this, correct, Siddesh. In this, when you're doing descending, only the last pass will have a swap. Otherwise, all the other passes will not have a swap. Correct. Okay. That all depends on the order of elements that is given to you. So in this case, it's almost in descending order. Therefore, only the last will be having a swap. Okay. So anyone has any questions about these two methods or yesterday's three methods that we learned? Yesterday we had learned two searching methods, one sorting, and today we have learned two more sorting methods. Okay. Okay. So I'll just stop.